In this unit, we will be talking about application management. So we will start creating by creating a very simple application. I have here the source code. It's a program that just outputs something on the screen and terminates. And this is the source code. I need to create the executable file with this command. This is a compiler. And here I have the executable file. Hello, this is the source code. If I run it like any other command in Linux, yes, it performs its work and that's it. Okay, so remember that this here, this file, contains the matching code needed to do what we want to do. Remember that this is going to be run by a CPU. The CPU only understands zeros and ones. This is matching code, like something like add, mob, uh, jump, whatever. Okay, so this file here contains this kind of instructions, and these instructions output something on the screen. That's the idea. So can we will we be able to just take this file? This is in our computer. Move this to another computer and run it. Will it work? Well, it depends, because the first thing we need to let's get some information about this file here. The first important thing here is the format of this executable file. This is an ELF file. This is a format. It's very complex. We are not seeing this in the course, but it contains not only the matching code, but another information about the executable file. So for this file to be able to run in another computer, the first thing it will need is to understand the ELF format. So if we move this file to another machine, this other machine needs to understand this format. Okay, so for example, if we take this from this machine and move the file to a Windows machine, Windows won't be able to run it because it doesn't understand this format. If we move it to a Linux machine, it will be able to understand the ELF format, so maybe we will be able to run it. Of course, the machines should have this architecture. So, for example, if we have moved this to an ARM machine, we won't be able to run it because the matching code here is for this kind of processors, not for ARM. Okay, so the first condition, it must has the same architecture. Second condition, it must understand ELF, but that's not enough for run in another machine, because this uh, this code, this executable file is dynamically linked. So what does that mean? Usually when we write a program, this program here, we don't write everything. We use something called libraries. So for example, for this scan, this line here tells that we are using std.io library. This library is for input-output library. So if we need to get something from the user or output something on the screen, we will probably use this library. And this library is just another bunch of code that someone wrote, and it must be in some place. Okay, so we are using a library. So our code, our executable file, it has some code that is ours and some code that is in a library. So for running this code in another machine, we will need those two things. We will need our code. This is hello C, and we will need all the libraries that this program uses. In this case, it's only using one library. We can see it here with this command. It needs this library. This library is the basic C library, and it's present in almost all, I think it's in all Unix system. But if we move this to another computer, we will need, okay, same architecture, understand ELF, and have all the libraries. This is a very common library, so probably if we move this to another Linux machine, it will work. But if we had a more complex program, maybe we will use very different libraries, something for network, I don't know, precompiled code, using whatever libraries we use here. They must be present here in the system where we pretend to run the executable file. And there is another problem because well, some puntualization here. The libraries, this program is dynamically linked. That means that in hello only contains our code, and the library is in another file. This is in another file. We can compile this with static linking. In this case, this will be together. The executable file will be much bigger, but we won't need the libraries in the other system. Okay, but we will return to this later. So we need the hello C. We will need the libraries, all the libraries that the program use. But maybe usually when we have a program, we need other kind of information. For example, we need config files. We need data files. For example, if we pretend to show images on the screen or whatever, we need data. I don't know, dictionaries, whatever data, some files, and the libraries, of course. So if we want to install this application, well, not in this case because it's very simple. When we pretend we need to install this application in another computer, we need to do all this. Move the executable, move the libraries, create the configuration files, maybe made some modification of the configuration files depending on the system, and copy all the data. So it's not as simple as just moving the executable. So if we want to install an application, we need to do all this. And this is not a simple process, and we will see in this unit how to do that in Linux systems.